Friends, when acetylene appears in a DGA report, this is no longer analysis. This is an emergency signal. Hydrogen warned you. Methane showed heating. Ethane showed progression. Ethylene confirmed overheating. But acetylene changes everything. Acetylene means extremely high temperature, electrical arcing, insulation breakdown, or internal discharge powerful enough to crack oil instantly. Even a small amount of acetylene is never considered normal. In today's Electroverse episode, we will decode acetylene, C₂H₂, in Transformer DGA. Why acetylene forms only under extreme conditions. What temperature levels it represents. Why ppm value is less important than presence. Difference between thermal faults and arcing faults. When acetylene demands immediate shutdown consideration. And how senior engineers respond without panic. Stay till the end, because acetylene is the gas that separates routine monitoring from emergency action.
In the world of power transformers, there's one gas that stands above all others as the ultimate danger signal. Today we're talking about acetylene, and if you remember only one thing from this entire discussion, remember this. Acetylene is not a warning, it's a danger signal. Let me start with something that might surprise you. While other gases in dissolved gas analysis give us hints about developing problems, acetylene tells us something completely different. It tells us that arcing is happening inside your transformer right now. Not tomorrow, not next week, but at this very moment. Acetylene, chemically written as C₂H₂, is what we call a high-energy fault gas. Unlike other gases that form during normal aging or mild heating, acetylene has very specific formation requirements. It needs extreme temperatures, typically above 700 degrees Celsius, and violent insulation breakdown. Think about this for a moment. Your transformer oil normally operates at maybe 60 to 80 degrees. When we see acetylene, we're talking about temperatures that are almost 10 times higher. According to both IEC 6599 and IEEE C57.104 standards, acetylene should be zero in normal conditions. Zero. Not low, not within acceptable limits, but completely absent. Any detectable amount, even 1 part per million, is abnormal and dangerous. There is no safe limit for acetylene. Now listen carefully. The presence of acetylene is binary. Present means problem, not present means safe from arcing. It's that simple. When acetylene appears in your DGA results, something serious is already wrong inside your transformer. But acetylene doesn't work alone. When we see it alongside hydrogen, it indicates active electrical arcing. The combination tells us that high-energy electrical discharges are creating these extreme temperatures. When acetylene appears with ethylene, it suggests a severe thermal fault that's escalating to arcing conditions. Either way, the message is clear: your transformer is in immediate danger. Here's what makes acetylene particularly dangerous. It represents energy release, not just heat. While other gases might indicate overheating that develops slowly over months or years, acetylene formation happens quickly. A sudden appearance of acetylene after previous readings showed zero means a new, rapidly developing internal fault with high failure risk. The engineering response to acetylene detection is not optional. First, reduce the transformer load immediately. Increase your DGA testing frequency to daily or even more frequent monitoring. Review all protection settings and ensure they're functioning properly. Plan for internal inspection as soon as possible. Prepare contingency plans for emergency replacement or bypass operations. What you absolutely cannot do is ignore acetylene or delay action. I've seen engineers make the mistake of thinking it's only a small amount or other gases are still low, so we're okay. This thinking is critical and leads to transformer failure. Acetylene means time is no longer on your side. The source of arcing can come from several places. Insulation breakdown in windings where coil-to-coil or coil-to-ground insulation is damaged and cannot maintain dielectric capability. Winding shorts, whether turn-to-turn, phase-to-phase or phase-to-ground. Loose connections, especially in high-voltage areas which result in high-energy discharges. All of these create the extreme conditions needed for acetylene formation.
In fault diagnosis, acetylene can be used in various methods. The Rogers ratio method, the Donenberg ratio method, Duval's triangle and pentagon methods all recognize acetylene as a critical indicator. But here's the key point. Regardless of which method you use, acetylene demands immediate action. Acetylene does not negotiate. It doesn't give you weeks to plan or months to budget for repairs. When it appears, your transformer is telling you that catastrophic failure is imminent. Transformers fail when acetylene is ignored. Think of acetylene as the last warning in the DGA gas hierarchy before complete failure. Other gases might give you time to plan maintenance, schedule outages, or order spare parts. Acetylene tells you that planning time is over, action time has begun. The formation mechanism itself tells us why acetylene is so dangerous. At temperatures above 700 degrees Celsius, the carbon-carbon bonds in oil molecules break and recombine into gases with triple bonds. This requires enormous energy, the kind of energy released during electrical arcing. The fact that acetylene forms at all means your transformer has already experienced these extreme conditions. From a practical standpoint, any transformer showing acetylene should be considered for immediate removal from service. The risk of catastrophic failure, with all its associated safety hazards and system impacts, far outweighs the inconvenience of an unplanned outage. Remember, dissolved gas analysis is a window into the internal health of transformers. Most gases give us trends and patterns to analyze over time. Acetylene is different. It's an emergency signal that demands immediate response. In the hierarchy of transformer fault gases, acetylene sits at the top, representing the most severe conditions possible. As power engineers, our responsibility is to prevent failures, not just predict them. When acetylene appears in DGA results, prevention time has passed. We're now in damage control mode, working to prevent catastrophic failure and ensure safety. The standards are clear, the science is established, and the engineering response is well defined. Acetylene in transformer oil means one thing: immediate action required. There are no exceptions, no special cases, and no room for delay. This is why acetylene is the last warning before failure. When you see it in your DGA results, your transformer is telling you that it's fighting for its life. The question is, will you listen and act? Or will you become another statistic in transformer failure records?
So friends, this is the real meaning of acetylene in DGA. Acetylene does not indicate stress. Acetylene confirms severe electrical energy inside the transformer. It tells you arcing or sparking is present. Oil is cracking instantly. And insulation damage may already be occurring. Remember this rule. Never forget it. Hydrogen to ethylene. Thermal story. Acetylene. Electrical arcing story. Even a few ppm of acetylene must never be ignored. When acetylene appears, you don't wait for trends. You investigate immediately, you correlate with protection events, and you assess risk to service continuity. If this video helped you think like a senior transformer diagnostic engineer, then support Electroverse. Like this video, it helps serious engineering knowledge reach more professionals. Comment below, have you ever seen acetylene appear suddenly in service? Subscribe, because this channel teaches DGA gas interpretation without confusion or fear. In the next episode, we move from oil to paper and decode CO and CO2, insulation life and aging logic. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.